So in the last video, we looked at finding the domain and range analytically. No pictures, no graphs, right? We were just looking at the functions. Well, in this video, what we're going to do is we're going to look at the domain and range of a function from a graph. Okay, so let's say we have a graph that starts right here and then does something like this. Okay, let's say this is some function f of x. Then what we can do is we can look at the domain and range by looking at all the x values. And one way of thinking about that is we can just drag, right? If we drag this graph to the x-axis, if I drag all of these points to the x-axis, notice that this is the furthest to the left that we can go, but we can go as far to the right as we want. This is our domain on the number line. And similarly, if we wanted, for range, we could drag everything to the y-axis. And if we drag everything to the y-axis, right, what's going to happen? What's the biggest we can get? Up here. And then we can go as far down as we want. That's going to be the range. This is kind of one method of looking at domain and range graphically. Just drag things, domain is inputs, x's. Drag it to the x-axis and look what x values we have. Range is the y values, the outputs. Drag everything to the y-axis and you can see our range there. Let's use this in a couple examples here. Example 4. Find the domain and the range for the following graphs. First graph, going to look like so. And let's say it starts with an open circle over here, and then kind of dips down a little bit, goes back to the origin, and goes down and to the right the whole way. Whoa! Like so. We can do the same thing that we did in this little example above. So for the domain, let's look at all the x values, drag everything, right? Drag everything to the x-axis and see what we have. If we do that, note that this is the furthest to the left we get. It's an open circle. It's not included, but we can go as far to the right as we want. Our domain starts at -3 and goes all the way to infinity. -3 is not included. Infinity is never included. This is what it looks like in interval notation. We can do the same thing with the y values. Drag the graph, the y-axis, and see what you get. Well, if we drag everything to the y-axis, this is a little weird here, because this point right here becomes an open circle, but it also hits it right here. So that's why we have a closed circle, because there's two y values, right? We have an open circle here and a closed circle here. We're still going to have a closed circle here, and we're going to drag it right down. Okay, so the y values, the biggest y value we get, is y equals 0. And the smallest y value we can get as small as we want. 0 is included. Infinity is never included. And that's our domain and range here. All right, we're going to do a couple more of these problems because it's really good to get. This is A. B is going to be one of our so-called toolkit functions. Okay, these functions that we are going to see a lot. This toolkit function is the absolute value function. It just looks like a V. Okay, if it's a positive number, you keep it positive. If it's a negative number, absolute value turns it positive. That's the absolute value function. We can do the same thing for domain and range. Domain, drag everything to the x-axis and see what results. Well, if you drag everything to the x-axis, well, we can go as far to the left as we want, right? This goes on forever. And we can go as far to the right as we want as well. The domain is the entire number line. The domain is all real numbers. You can use that R, or you can write negative infinity to positive infinity in interval notation. But the range is a little different, right? If we drag all the function to the y-axis, note that nothing happens down here, right? If we drag it to the y-axis, the smallest we ever get is this. And what's the biggest we ever get? Well, it keeps on going up in both directions. It can get as high as it wants. So the smallest it ever gets is 0, which is included. We do hit 0 right there. And the biggest it ever gets is infinity. That's the domain and range of the absolute value function. Let's do some more. Part C. Let's look at the square root function. In fact, I'm actually going to draw a couple more graphs right here. And I want you to pause the video and see if you can come up with the answers for these. And we get the same ones. So let me finish drawing these graphs. Pause the video and see if you can get to the same thing that I get to. This is another toolkit function. This is the square root function. It's another function right here. Has an asymptote at the x and y axis. So it's getting really close to the x-axis, and it's getting really close to the y-axis, but it's never touching. This is the toolkit function 1 over x squared, one of our basic functions, if you will. Let's do the straight reciprocal function, which is very similar. Only now it's negative over here, and it has a slightly different shape. Reciprocal function. And another toolkit function, the cubed root function. Let's draw a better one than that. And this kind of looks like so. This is the cubed root of x. So pause the video, see if you can find the domain and ranges of these, and then we'll go through them together. All right, so if you look at all the x values for this first one, the furthest to the left we can go is here, but it goes as far to the right as we want. Our domain for the square root of x is 0 to infinity. Looking at the y values, if we drag everything to the y-axis, the lowest we can ever go is right here, and the highest we can ever go, we can go as high as we want. The range is the same. 0 to infinity. I'm not going to box these. I don't think we need to. Over here, this one's a little trickier. Let's start with the domain. We can go as far to the left as we want. We can go as far to the right as we want. But notice that we never touch 0. We never have a value when x equals 0. And in fact, using the material from the last video, x can't be 0 because we can't divide by 0. So this has everything except 0. Use an open circle here or parentheses for our domain. The domain is going to be everything except 0. Negative infinity to 0, union 0 to infinity. Or you could write this in set builder notation, the set of all x such that x is not equal to 0. Similarly for the range, notice there's nothing down here, right? It gets really close to 0. The y value gets really close to 0, but it never hits it. You can use an open circle or parentheses, but we don't ever touch 0. But we can get as high as we want. So the range is going to be 0, which never gets touched, it never gets hit. 0 has a parenthesis, and it can get as big as we want. Or again, you can write this in set builder notation. If we use range, we usually use y. The set of all y, such that y is strictly bigger than 0. We do some similar things for here, follow the similar process. Domain is still going to be everything except, whoa, not that. Everything except 0. And the range still is going to be a little different. It's also going to be everything except 0. You can compare this one, the reciprocal function, with the reciprocal squared function. The cubic one, the domain and the range are both going to be all real numbers. All right. Let me know if you have questions on these. That's domain and range. Let's do one application problem to finish off this video, and then we'll move on. Oops. This is going to be letter G. Wait. I didn't even letter these. D, E, F, G. All right, so let's look at a problem over here where we're looking at the Alaska crude oil production. The years here are going to be every 5, so 1975, 1980, 85, 90, 95, 2000, and 2005. And on the other axis, it's going to be starting at 200. And then every 400 after that. And it's going to start a little bit, you don't have to have a really exact graph, but it's going to start a little bit above 200, then kind of go down like this. Then it kind of shoots up really fast up here, and then maybe kind of moseys on around and gets kind of high again. And then it kind of meandered down over here. Doesn't need to be a really precise graph, but we're going to look at domain and range. Well, 1975, well, that's not our lowest. What's the furthest to the left? Furthest to the left for domain is 1970. Furthest to the right is 2005 for this graph. This graph only incorporates these years. For the range, we have to look at, well, what's the lowest we ever get? Lowest we ever get is here. Maybe that's like 100 or so. Highest we ever get is, I don't know, maybe something like this, almost 2200. You're going to have to estimate a little bit. But when we estimate, we're going to say, okay, maybe the lowest we ever got was about 100. Oh, I forgot my units here. Thousands of gallons? I don't know. And then the biggest it's ever going to get is, I don't know, maybe that's 2150. You kind of have to estimate. Guess based on the graph. Okay. But you can also find domain and range for application problems. Good luck. Let me know if you have questions.